In this example, determine shear and moment in beam as a function of x. First of all, this beam has three critical points: 1, 2, and 3. So we need two sections, 1 and 2.
Sorry, Mr. Pardin. My question about the left side, this support. This is a fixed support or
Yeah.
pin support?
Yeah, this is a fixed one.
This is a fixed support, yeah?
Yeah. Question?
I have a question from the, it's too general. Maybe the answer is clear. But we are assuming different x's. We have x1, x2
Yeah.
for each part of the structure. We assume, but at the end, in integration, we are doing summation of all of them.
Yeah.
But they are different. How we do the summation?
Actually, x1, x2, x3, everything is x. We use x1, x2, or x3 just for clarification in different equations, because we have m1, m2, m3. When you use x1, for example, here for column, then you know x1 is for column, but actually it's x. And in this region, from 0 to 3 meters. When you use x2 for beam, it means x2 is beam, and for this region, from 0 to 2.4. The difference is, that's it, nothing more.
When you take the section is for x1 in the first, yeah?
Yeah. Again, we use the same method for calculation of W function. We have this function for this part, and also we have constant value 10 kilonewton per meter for this part.
In this method, in a section for solving the trusses, we consider all forces as tension. Why you consider FBC as a compression?
Don't rely on this, what I captured from the book, but you can always, and I emphasize on this, always use tension forces. Then if you get positive value for tension, then you have real positive, and if you get negative, you have compression.
Tarzan, we started the moment diagram at point 0. The reason is the slope of, on the V diagram, the slope is 0 at the left
end
and at the beginning.
At the beginning.
At the 0
Always
x direction.
at this point.
Yeah, we start at this point.
Why it is 0, right?
Right.
Why it is 0? Always you start from 0, and at the end you should have 0. If you don't have 0, you have something wrong with the calculations. So, for example, if you have a fixed beam, something like this, okay? In this case, shear force is something like this, and moment start from 0, but at the beginning you have a negative moment. If the length is L, then M is minus PL, okay? But always you start from this value, then because you have a concentrated moment minus PL, you have a jump to minus PL at the end of this section, and actually expanding this method for other elements. We have something about this method. The method we're talking about is just applicable for the case we have no lateral displacement. What's the meaning of this? For example, if you have frame like this and you apply a uniform here, and also you have another frame, exactly the same one, and you apply the distributor load like this, okay? In which case, case 1 or case 2, the method of moment distribution based on our assumptions by now is applicable here?
Between point D and E, shear is positive. But
Yeah.
for moment, we moved from -3 to -6. It shouldn't be positive.
-6 to 0. This 6 is x, right?
So my question is why -6? Because shear is positive.
Why this
Mhm.
-6?
Yes.
This -6 is related to what we had before this point. So what you have after this point affect to the diagram after this point. So you can't ask why the shear is positive but moment is negative. We have two
Yes.
different parameters.
Sorry, if this frame, we have another component on the other side of the frame, not fixed at the top. For example, we have another column that extended to down. Yes, for example. And we have another concentrated load on the column, horizontal.
On the column, here
On the,
or here?
no, on the column, not on the beam.
Okay.
It causes sway on that case.
This situation you mean? This is the situation you're talking about that?
No. You know, we have
Mm.
one column and one beam in this case. If we have another frame that has two column and one beam on top, and on that,
This
yes,
one beam, two columns.
no. You have
Without this part?
yes, without this part. Yes,
Okay.
exactly.
This
Yes, for example, one of them is fixed and one of them is hinged.
hinge.
Yes,
And we have the load
yes,
here.
one concentrated load on the beam and one concentrated load on the column, horizontal
Here you mean?
concentrated.
Here?
No, on the first column.
Okay. Anyway, the
No,
structure.
the horizontal at the middle of the. Yes, at the
Hmm.
yes.
Here.
In this case, we have sway.
Even if you don't have here, even if you have no load on the column, it is with sway. Why?
It's with sway.
It's with sway, yeah. Because you don't have symmetrical case. Here you have fixed, here you have hinge. So this is with.
And if we had that load on the column, again we have sway too.
Of course.
And if we want to calculate this structure, we have to calculate the moment at first without sway, and
It's
then
not
we have-
possible for you because I mentioned the method of moment distribution for these cases. It's a little bit more complicated because in previous exams we had nothing for this situation. I ignored this part. So what I had here, for example, you see, we have sway here, we have sway here. We have to solve the structure 3 times, and then we have to make this system of equations. So because shear here is 0, the slope here is 0, and shear is negative because it is downward, so we have negative slope. So the only curve we can draw is this one, starting from 0 slope to negative slope. Then for the rest, the second half of the beam. At the beginning we have downward distributed load, so we have negative slope. At the end we have 0 shear or shear slope. The area under distributed area is 9 and downward. So from 0, 9 units to we have -9, and based on the slopes, negative slope, 0 slope, the only possible curve is this. Finally, at the end we have 9 kilonewton upward, so finally we have 0. For moment for this beam at the beginning and at the end are 0 because we have roller and joint support. So starting from 0 and ending to 0, at the middle we have something, but the difference between this middle and the beginning is this area.